Hello everybody, Allie and I did basic facts and whole numbers. Kindergarten students can count and kindergarten and first grade students can count and are introduced to patterns of numbers up to 100. Most importantly, kindergarten and first grade students can begin to think about groups of 10 as a unit. Second grade students begin to formally connect those ideas to our place value system. Third and fourth grade students can extend their number sense to numbers up to 10,000 in many contexts. Fourth and fifth grade student number sense begin to include not only whole numbers but decimals as well. A significant area of developing number sense for students include composing numbers or putting numbers together and decomposing numbers, taking numbers apart. Students practice these skills by solving addition and subtraction problems with 2- and 3-digit numbers. The struggle to create their own computation strategies enhance their place value understanding and provide solid foundation for various methods of computation. This is why it's so important for us as teachers not only to give students an algorithm and expect them to solve the problem. We have to give them several strategies to choose from so they can work through those strategies and figure out what works best for them in order to really understand the concepts. Kindergartners' approach to 2-digit numbers includes one or more than and count by ones. Kindergarten student cannot comprehend but place value. When asked to count 14 blocks, a kindergarten student might say there is 1 in 4 blocks, not understanding that the 1 represents a group of 10. When assessing the trajectory, ask a student to count 48 tiles, and if he or she counts by ones, she is in the pre-base 10 stage. If he or she separates the tiles into a group of 10, the student is in the base 10 stage. Pre-base 10 students will explain their counting with, I know it's 48 because I counted them. These students think of 48 as a single numeral, not as groups of 10s and singles. Even naming the 1s and 10s place does not indicate full understanding of place value. The same with naming base 10 blocks. They are in the unitary stage, where there's no grouping of 10s, everything is just one unit. Understanding the basic idea of place value requires a combination of difficult ideas of grouping 10s and procedural knowledge of how these groups are recorded, how numbers are written and why, and how they are spoken. They also must understand the word grouping in context. This could be confusing for all students, especially ELLs. As teachers, we use grouping to describe guided groups working together in pairs or in small groups, group work, and it can be hard for these students to take that word and use it in a mathematical context rather than just in everyday language. Counting by ones and base 10 grouping result in the same answer. Group A, in the figure to the right, is the pre-base 10 approach to counting. Students using this approach would just count every tile and say, I counted them, in order to tell the answer. Group B is the base 10 approach, where all tiles are grouped into groups of 10, and there are 3 singles. A student in the base 10 stage would count all groups of 10 and the singles and tell you the answer. Group C is a combination of both, or equivalent. Group C has some groups of 10 and some singles. All groups represent the same number. Students with an understanding of place value do not need to count each group. Students in pre-base 10 will not recognize that each group is the same. They will feel the need to count each tile one by one. Students can count objects shown in the previous slide by using one of 3 strategies: counting by ones, counting by groups and singles, and counting by 10s and 1s. In the counting by ones strategy, students usually begin in the counting by ones strategy. This is the only way for them to tell how many there are. And this strategy is used before base 10 development. Counting by groups and singles, counting groups of 10s in single unit. Let me start over. Counting by groups and singles is when a student counts the groups of tens and the single units separately. This stage must be preceded by the count by ones approach. Counting by tens and ones is how most adults would count groups of 10. For example, we would say 10, 20, 30, 40, 50, 51, 52, 53. Some questions that would help students make the connection from counting by ones approach and the next two strategies might include: when you ask a student to count objects, ask if they first counted by ones, ask what will happen if we count these by groups and singles, or by tens and ones, depending on the language you want to use in the classroom. If they group the objects into tens and ones, say, how can we really be certain there are 53 things here? Or how many do you think we will get if we count by ones? This is just helping make the concepts concrete in their head, that whether they count by ones or group them into tens and ones, they will have the same answer. Students must be able to make those connections on their own. They can't be told. Saying numbers can be connected to 3 counting strategies. Count by ones. You could say 1, 2, 3, 4, 5, all the way up to 53. Counting by groups and tens and singles, 5 tens and 3 ones. This is not the standard way of saying numbers, but it is acceptable. It's called the pre-base 10 language, and it's helpful for ELLs because base 10 language is used in a lot of different languages. Counting by groups of tens and ones, saying 10, 20, 30, 40, 50, 51, 52, 53. Counting this way will cause the counter to say the number in standard form, 53. All 3 methods of counting are coordinated as a principal method of integrating the base 10 concepts, the written names, and the oral names. Base 10 language can help students understand how to write numbers. The form ones on the right, tens to the left of ones, and so on can be explained using both figures to the right. It is important for students to see a group of 10 as a group of 10 ones and a group of 1 10. It can be difficult to say too. It is important to include physical models of base 10 concepts. Do not rely on these models to teach the concept. They should be used for practice after the students have made their own connections. Base 10 models can be separated into 3 categories: groupable, pre-grouped, and electronic. Groupable models might include tongue depressors, beans, classroom counters, coffee stirrers, any other objects that can be easily grouped around the classroom. Pre-grouped base 10 models would be like base 10 blocks. These models cannot be separated. 10 ones must be traded for a tens piece, 10 tens must be traded for a hundreds piece, and so on. Students must understand that a tens piece is equal to 10 singles, etc. Electronic models are not exactly physical models, but they are the virtual representations of the base 10 concepts. The base blocks applets at the National Library of Virtual Manipulatives and Pearson's Education eTools are 2 examples of where to find electronic base 10 models. The electronic models are useful for several reasons. They are free, unlike the base 10 blocks. They are practically unlimited, and they are easily grouped and regrouped. They can be used for students with disabilities. Non-proportional models include money, beads, colored chips, or colored blocks. For example, if you were to use a colored chip, a blue chip equals 100, a red chip equals 10, a yellow chip equals 1. These are non-proportional models because a blue chip is not necessarily 100 times a yellow chip. They should only be used for reinforcing base 10 concepts because they don't actually represent 10 more or 100 more of something. The figure to the right represents a pyramid of base 10 instruction. The top shows the base 10 concepts, and the bottom corners are the oral and written names for numbers. Although these concepts are separate and require separate attention, they also coincide. The following activities can be used for base 10 instruction. Find a group of objects that students will be interested in. Number of pockets, shoes, markers in a box, tiles on the floor, something between 20 and 100. Encourage students to suggest different ways of counting those objects. After trying several ideas, talk with students about what worked best and what did not work. If counting by tens is not suggested, make the suggestion yourself. Have pre-prepared bags of different kinds of counters. Beans, straws, washers, toothpicks. Again, anything that can be grouped easily. Give students a worksheet similar to the one to the right. Students empty bags and count what's inside. First they record the amount as a number word, then they group the contents into tens and the grouping is recorded. They will return the counters to the bags, rotate stations, and count the next bag. They will record their groupings there as well. Introducing phrases such as 6 ones, 8 tens, or 4 hundreds can be difficult for teachers and students. 10 ones make 1 10. That can be a really difficult phrase to understand for these students. 10 has become one thing, a noun, rather than many things. Start by using words like bundles, bags, cups of tens, however you're using base 10 models in the classroom. Introduce the more general phrase, groups of tens, and then next move to just tens. Hundreds can also be difficult for them to understand. Hundreds are now 100 single objects, 10 tens, and one thing. It is important for students to understand that hundreds do represent all three of those things, and they must make the distinction between them. Too many tens is an activity to help students begin grouping tens into 100s. To show students a group of 150 to 1,000 objects, beans for example. Have the students record an estimation of how many beans there are. Ask how they came up with that estimate. Give pairs or triads of students a handful of beans. Students will separate the beans into cups of 10, collect leftover beans and put them into groups of tens. Ask, how can we use these groups of tens to tell how many beans we have? Can we make new groups from these groups of 10? What is 10 groups of 10 called? Have large baggies to empty 10 cups of 10 beans. When all groups are made, record on the board how many hundreds, how many tens, and how many ones there are. How we write and say numbers are conventions, not concepts. Students must be told rather than learn through problem-based activities. This could be difficult for ELL students, as they are just learning the language. First and second grade students must connect base 10 concepts and the way we write numbers. They know the words to say, but do not yet understand in terms of tens and ones. It is important to use base 10 materials and use base 10 language when introducing number names. Remind students that the teens are an exception and are backwards from the usual pattern. The following activity will help students connect the bottom two corners of the pyramid. Show a 10 by 10 array of dots on the projector. Cover all but 2 rows as shown on the figure to the right. Ask the students how many dots are shown and point out that there are 2 groups of 10 to make 20. Show another row and ask the same questions. Emphasize that 5 tens is called 50, not 5t. Continue all the way through 90. Continue to practice different groups of tens out of order. ELLs might need more emphasis on the difference between 15 and 50, 16 and 60, and so on. Use the same 10 by 10 array to practice tens and ones. Show 4 rows and 1 dot on the 5th row. Explain it as 41. Continue with other numbers. Familiarizing students with how numbers are written can be done using place value mats and number cards. To use place value mats, have students organize pre-grouped objects into the appropriate spot on the mat. To use number cards, make 27 cards, 1 for each 100, 100 through 900, 1 for each 10, 10 through 90, and 1 for each 1 through 9. The cards should fit on top of each other so the hundreds, tens, and ones place can be viewed by students. Combining the two, have students place the appropriate cards on the place value mat as they separate the grouped objects to see how the numbers would be written. To assess place value concept, use one of these three diagnostic interviews. Interview number 1. Use 36 blocks. Ask students to count the blocks. Have the student write the number. Circle the 6 in 36. Ask, does this part of your 36 have anything to do with how many blocks there are? Do the same with 3. There are 5 levels of understanding when using interview number 1. First level is single numeral. The student sees numbers, for example, 36, as one unit, and the digit 3 and 6 have no meaning on their own. Position names. The student knows the correct position names for the place value, but do not actually make the connections. Face value. A student can match 3 blocks with the 3 and 6 blocks with the 6. Transition to place value. 6 blocks. The student can match 6 blocks with the 6 and the remaining 30 blocks with the 30, but not in groups of 10. Full understanding is when the 3 is correlated with 3 groups of 10 blocks, and the 6 with 6 single blocks. Interview number 2. Write the number 342. Have students read the number. Have the students write the number that is 1 more. Ask for the number that is 10 more. Watch to see if the student is counting on or counting back, or if he or she immediately knows the answer. A student who is counting on or counting back would be in the pre-base 10 stage. A student who is understanding base 10 concepts will immediately know the answer. Ask the student to write the number. Interview number 3. Ask the student to write the number that represents 5 tens, 2 ones, and 3 hundreds. Note, the task does not give the places in order. If the student writes 352, ask them to show you the number with base 10 materials. What could be the common misunderstanding if the student does not write the number correctly? Using a hundreds chart in the classroom can also help students practice base 10 concepts. You can use a transparent number chart with number cards. Cover or highlight different numbers or patterns. Remove numbers and have students put them back where they should go. Relationships with landmark numbers are also important to understand for students. Multiples of 10, 100, and sometimes multiples of 25 are landmark numbers. Students start using landmark numbers when finding differences in sums. Connecting place value in addition to addition and subtraction are important for all grades. It is not necessary to wait for students to fully develop place value understanding before giving them opportunities to solve problems with 2 and 3-digit numbers. Activity number 1, 50 and some more. Say or write a number between 50 and 100. Students respond with 50 and blank. For example, using the number 63, the response is 50 and 13. Any landmark number can be used. Activity number 2, calculator challenge counting. Students press any number on the calculator, for example 27. They press plus 10, but before pressing, they say the sum to themselves. They continue adding 10 until they make 8. For a younger or struggling student, start with a number under 20. For students needing a challenge, start with a 3-digit number. Or they can also begin adding more challenging numbers, for example, 5, 7, 9, or any other unconventional number. The same activity can be used for subtraction. It is important to connect these base 10 concepts to the real world. Encourage students to look for numbers outside of the classroom. Students under 2nd grade should think about numbers under 100 first, and then the numbers up to 1,000. Have students look for numbers around their school, on the playground, at home, and on the TV. Discuss with students what we can do with numbers. They can make graphs, tell stories, draw conclusions, make predictions and comparisons, and many, many more things. It's also important to help students conceptualize large numbers. and we can create references for special big numbers. Start collecting something the students might be interested in. Try to reach 1,000, 10,000, or 100,000. This can include bottle caps, marbles, soda can, pop tops, anything that is small and can be collected in large quantities. Illustrate large numbers. Begin a class project where each student contributes a certain amount of something until the class reaches 1,000, 10,000, or 100,000. This can be dots on paper, paper chain links, or anything that can be added to on a daily basis. Estimating large quantities. Have the class or a whole school make estimation of large numbers to be explored over a few weeks or a quarter. For example, how many grains of rice would fill a cup or a gallon jar? How many pennies can be laid side by side down the entire hallway? Or how many quarters could be stacked in one stack from floor to ceiling? There are critical learning phases for understanding the structures of 100s, 10s, and 1s that all students must recognize. Students counts 100 as a single unit, knows total instantly when the number of hundreds, 10s, and 1s is known, mentally adds and subtracts 10 and 100 to any three-digit number, knows the number of hundreds that can be made from any group of 10s and the number of 10s left over, determines total value of group of 100, 10s, and 1s by recognizing them into all possible hundreds, then all possible 10s with leftovers. Describes any given three-digit number in terms of its value in 1s, in 10s, and in hundreds. Using symbols. Interprets three-digit written numbers with models of hundreds, 10s, and 1s, and records the number of hundreds, 10s, and 1s using appropriate symbolization. The critical learning phases for adding and subtracting three-digit numbers is add and subtract multiples of hundreds without counting, knows parts of 100 in 10s without counting, mentally breaks apart 100 into 10s and 1s and recognizes that ones of the 10 will be broken up. When adding numbers that result in 100 and some more, determine what part of the number is needed to make the next 100 and what part will be left over. Combines the resulting hundreds, 10s, and 1s without counting. Breaks apart and recombines hundreds, 10s, and 1s when adding and subtracting. Critical learning phases for understanding the structure of thousands, hundreds, 10s, and 1s. Counts 1,000 as a single unit. Knows total instantly when the number of thousands, hundreds, 10s, and 1s is known. Mentally adds and subtracts 10 and 100 to and from any four-digit number. Knows the number of thousands that can be made from any group of 100 and the number of hundreds left over. Describe any number from 1,000 to 10,000 in terms of its value in 1s, 10s, hundreds. Determines total value of groups of thousands, hundreds, 10s, and 1s by recognizing them into all possible thousands, hundreds, 10s as leftover 1s. Interprets four-digit written numbers with models of thousands, hundreds, 10s, and 1s. So for some base 10 practice, you all will solve these base 10 riddles. There's 8 riddles, all having to do with these base 10 concepts that we have been talking about. So take about 5 minutes to solve all 8 riddles. Here are the answers to the riddles. 1, 63, 2, 418, 3, 330, 4, 2, 5, 1, 6, 351, 7, 85, 8, 47, and 3. Now, take about 5 to 8 minutes coming up with at least 10 new riddles that could be used to assess students' base concepts understanding.